It's official. Tesla just fired up their Model 2 production line, and it's building complete electric cars every 19 seconds for $10,597. That's 3 times faster than Toyota's Corolla line, while costing less than a used Honda. The secret weapon? A 50,000-ton Giga press that's casting entire vehicle sections in single pieces, eliminating 70-plus parts per car. But here's what's shocking. This isn't a prototype or a test run. The line is operational right now. So how did Tesla crack the code that every automaker said was impossible? Sound impossible until you see how they're doing it. The 50,000-ton monster that changed everything. Here's where it gets real. Tesla installed Giga press machines that operate at 50,000 tons of clamping force. To put that in perspective, traditional automotive presses run at 2,000 to 6,000 tons. Tesla's new machines deliver 6 times more power than their previous generation. Why does this matter? Because higher tonnage means you can cast bigger, more complex single pieces with thinner walls. Up to 6.5 feet in length, with walls as thin as 0.08 inches. That's aerospace-level precision in automotive manufacturing. Industry leaks from suppliers in Mexico and drone footage near the upcoming Gigafactory site reveal something wild. The production line uses 2 parallel assembly tunnels, each synchronized by fully automated robotic cells. Together, they're designed to complete one vehicle body every 19 seconds. Do the math. That's 189 cars per hour, over 1 million units annually, assuming 14-hour days, 6 days a week. Toyota's Corolla line, one of the world's most efficient, takes 57 seconds per vehicle. Tesla just tripled that speed. How is that not causing panic in Detroit and Tokyo right now? But here's the twist nobody saw coming. Instead of the traditional sequential process, welding, then painting, then assembly, Tesla's Model 2 uses modular unibody castings that require only 2 large Giga press molds. Each mold handles an entire front or rear section, which then clicks into a central battery chassis within seconds. This click-fit concept has been in development since 2022 under the code name Project Redwood. One casting replaces over 70 individual stamped metal parts that would normally need separate welding, inspection, and assembly steps. Think about what that eliminates. Dozens of robotic welders, quality checkpoints, storage space for parts, potential failure points. Every eliminated step shaves seconds off the build time and hundreds of dollars off the cost. This isn't just faster, it's fundamentally different manufacturing physics. Speed means nothing if quality suffers. So how does Tesla maintain precision at this pace? They deployed something called Autoline OS, an AI-driven conveyor control system where robotic arms communicate directly with each other, adjusting movements in milliseconds based on camera feedback. Early insider reports claim this reduces idle time by 65% compared to the Model 3 line in Shanghai. The entire production line behaves like one adaptive organism, not 300 isolated robots. Here's the part that sounds like science fiction, but is actually happening. Laser-guided optical calibration checks over 1,200 reference points on each vehicle in real time. Instead of quality control happening at the end of the line, the AI corrects misalignments as they occur. They've merged quality assurance into production itself, maintaining tolerances within 0.2 millimeters. That's aerospace manufacturing standards on a car assembly line moving every 19 seconds. Can you imagine the computing power required to coordinate that many variables simultaneously? And here's the kicker. The system tracks over 2,000 data points per vehicle. Everything from paint viscosity to the exact torque applied on battery bolts. Any anomaly triggers an automatic adjustment in under 2 seconds. No line stoppage, no human intervention needed. Traditional car factories have been built the same way for over a century. Separate buildings for body shop, paint shop, general assembly. Each isolated because welding generates sparks and fumes. Painting requires dust-free conditions. Final assembly needs moderate temperatures. Tesla said, forget all that, and created what insiders call the unboxed process. Instead of isolating entire buildings, they're creating localized environmental zones around specific operations. High-precision laser welding happens inside portable clean chambers that move with the vehicle. Paint application uses electrostatic deposition in compact mobile booths. Battery installation occurs in climate-controlled pods, maintaining humidity below 15% to prevent condensation. The vehicle flows continuously through the factory without ever stopping for environmental transitions. Industrial engineering models estimate this cuts total assembly time by 22% to 28%. But wait, there's a detail here that changes everything. The Giga presses are positioned just 150 feet from the main assembly line. Automated vehicles transport castings while they're still over 300 degrees Fahrenheit, using residual heat for thermal fitting. This aerospace technique ensures parts expand during installation and contract as they cool, creating tighter tolerances than room temperature assembly. The implications? A 19-second cycle could let Tesla match Toyota's entire annual Corolla output with just 2 gigafactories. Now let's talk about the price that has everyone skeptical. A Tesla for $10,597? Here's how the economics actually work, and why it's not as crazy as it sounds. Giga casting alone saves $1,100 to $1,400 per Model 2. Traditional body production involves hundreds of stamped steel panels, requiring multiple operations, storage, inspections. Tesla's approach uses single aluminum castings for entire sections, cutting body shop space by 30% in assembly time from 6 to 7 hours to under 90 minutes. Multiply those savings across 1 million vehicles annually, and you're looking at over $1 billion in cost reduction just from casting. Battery costs tell another story. While earlier EVs used modular pack designs with individually installed cells, Model 2 uses fully integrated 2,170 cell packs installed directly on the conveyor. Automated battery insertion aligned with the chassis in one seamless step cuts labor by up to 12 hours per 1,000 vehicles. Add bulk purchase deals for cells, and battery cost per kilowatt-hour drops to under $80. That's a game-changing number. Here's where it gets interesting. Tesla reportedly locked in long-term fixed-price contracts with aluminum suppliers at 82 cents per pound, roughly 18% below current market rates for aerospace-grade material. Battery cell contracts are structured with volume-based pricing that drops the per-cell cost by 12 cents for every 100,000 units purchased beyond 5 million cells annually. At Model 2's projected volume, Tesla hits this threshold within the first 4 months of production. The software and electronics are tailored for efficiency too. Rather than the full sensor array from Model S or X, Model 2 employs a streamlined AI module delivering essential autopilot features while reducing hardware cost by roughly $1,000 per vehicle. The unboxed production line minimizes internal transport and storage, saving another $350 to $400 per vehicle annually in logistics alone. Add it all up. Giga casting saves $1,200, battery automation and bulk pricing cuts $1,800, streamlined electronics drops $1,000, logistics efficiency adds $375. That's $4,375 in cost reductions before considering the 19-second cycle's impact on labor and overhead. Industry experts estimate automation and AI optimizations reduce overhead by another $1,200 to $1,500 per vehicle compared to the Model 3 Shanghai line. Let me put this in perspective. If Tesla can build a quality electric vehicle every 19 seconds at $10,597, they're not just competing with other EVs. They're threatening the entire affordable car market. Every second saved on the production floor cuts costs in power, labor, equipment depreciation. Musk has said for years that the machine that builds the machine is more valuable than the car itself. The Model 2 line might be where that vision finally proves true. 2 parallel lines in one gigafactory, potentially a second facility overseas, all running at this speed. We're talking about production capacity that could reshape global automotive economics. But here's the question nobody's answering yet. If Tesla achieves this at scale, what happens to manufacturers still using traditional assembly methods? Can they compete? Or are we watching the beginning of an extinction event for legacy automakers? Drop a comment. Do you think the $10,597 price is realistic? Or is Tesla hiding costs somewhere? And which part of this production line would you want to see in person? The 50,000-ton Giga press, the AI coordination system, or the automated battery integration? Let us know what you think. Here's what this really means. Building a quality EV every 19 seconds for under $11,000 isn't just disrupting the market. It's rewriting manufacturing itself. That opening question? What happens to everyone else? Simple. Adapt to this efficiency or become irrelevant. This is why Tesla spent years perfecting the machine that builds the machine. The Model 2 line proves it works at scale. Replicate this in Mexico, China, Europe. We're watching a revolution extending beyond cars to solar, batteries, even spacecraft components. And this is just the start. Full capacity hits late 2025, then these techniques apply to Cybertruck and Roadster. The question isn't whether competitors catch up, it's whether they survive the attempt. Brand new Tesla for used Civic money. What happens to the used car market? Dealerships? Traditional financing models? Your take. Does this accelerate EV adoption beyond predictions, or are there hidden challenges? Which legacy automaker adapts first? This is Tesla Zone, breaking down innovations, reshaping transportation. The Model 2 proves the future of manufacturing is here, moving at 19-second intervals.